Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons. And in today's lesson, we are in the complex numbers system section. If you haven't already, please subscribe to the channel, ring the notification bell, and leave a comment on what you'd like to see in the next lesson. Now, in today's lesson, we are going to look at this very interesting question here that asks us to show that sine 5 theta is equals to cos fifth theta minus 10 cos third theta sine squared theta plus 5 cos theta sine fourth theta. All right, so we have that question there. Now, we should put in mind that these questions make use of de Moivre's theorem. Now, if you remember de Moivre's theorem, we said if you have cos theta plus I sine theta raised to the nth power, what you're going to get is something like cos, the power drops inside, so that will be n theta plus I sine, the power drops inside, so that will be n theta, like that. So that is what de Moivre's theorem. So now looking at this, we can assume that this might have come from the imaginary part of de Moivre's theorem, because you have sine n theta, so probably the n is actually the 5 there. So we can assume to say, so we say assuming, so this is an assumption which will later be dealt with. So assuming this came from de Moivre's, so what we have is sine 5 theta. Okay, what we have sine 5 theta. So what we're going to have here is cos 5 theta as well. So we're just replacing back. So now, according to de Moivre's theorem, this is equal to, the 5 can go up, so that would be cos theta plus I sine theta. We simply take the 5 outside, so this is equal to that, according to de Moivre's theorem. So now, this is just an assumption. We're going to expand this side of the equation, and we're going to denote where exactly sine 5 theta is. Is sine 5 theta on the imaginary part, because this is the imaginary part, or is it on the real part? So we are going to compare what will expand here for the real part and the imaginary part, and we'll see which part, the real part or the imaginary part, gives us this. Okay, and after we see from this where we have this, we will know exactly where sine 5 theta might have come from. So so let's expand. So how do you expand this part? So we're going to let this part be A. So we're going to let this part be A and this other part to be B. So basically we have A plus B raised to the power 5. Now, how do we expand this? So we expand this using, we can use binomial theorem, or we can use Pascal's triangle. So, but let me know if you have no idea on that. So, but basically the coefficients will be 1, 5, 10, 10, 5, 1. So those are the coefficients for the expansion. So where we're going to have a to the power 5, a to the power that we have here 5, then b to the power 0 plus, let me just reduce everything here. Okay, then we're going to have 5. Remember the coefficient, the other coefficient was 5. Then a to the power, the a reduces by 1, so that will be 4. Then b increases by 1, then plus 10, a reduces by another 1, so that will be 3. E increases by another 1, so that will be 2. plus again 10, then a reduces by 1, so that would be 2. B increases by 1, that would be 3. Then plus 5, a reduces by 1, so that would be a, and b increases by 1, that would be 4. And finally plus 1 times b, a to the power 0, b to the power 5. So that is just an example of how you can expand that. Okay, so but for those that don't know what is going on here, we're just using the binomial theorem. So the binomial theorem, let me just write everything here. Okay. All right, so we are basically using the binomial theorem, and what the binomial theorem says is that if you have a plus b raised to the nth, this is equal to the sum you're adding from x is equals to 0 all the way to where n is ending, and you have n choose x, then a, which is this part, raised to the power x, then b raised to the power n minus x. So where when we have a plus b to the power 5, this will be summing x from 0 to 5. Then our n here will be 5, so 5 choose x, then a to the power x, b to the power n is 5 minus x. Then we'll start moving from x is equals to 0, x is equals to 1, x is equals to 2, x is equals to 3, until we reach x is equals to 4, x is equals to 5. Okay, so for x is equals to 1, for x is equals to 0, what we're going to have here is 5 choose 0, so that would be 5 choose 0. Then a will be to the power 0, then b to the power 5 minus 0, then plus because of the sum. Then when x is 1, that will be 5 choose 1, a to the power 1, b to the power 5 minus 1, plus 5 choose 2, a to the power 2, b to the power 5 minus 2, plus 5 choose 3, a to the power 3, b to the power 5 minus 3, plus 5 choose 4, a to the power 4, b to the power 5 minus 4, plus 5 choose 5, choose 5, then a to the power 5, b to the power 5 minus 5, which is basically 0. So when you simplify this, what you get is, so you simply punch 5 choose 0 on your calculator. A to the power 0 is just simply 1. So when everything is simplified, you get this expansion that we have here. So now what we are going to do here now, we're going to replace. All right, so after simplifying that, we know that our a is equals to cos of theta and our b is equals to I sine of theta. So we simply replace in there. So that will be a to the power 5. So that will be cos 5 power 5 of theta. Then b to the power 0 is simply 1. So we can just leave it like that. Then plus 5. A to the power 4. So that will be fourth of theta. Then b is I sine theta, so we simply write there I sine theta. Then we are here plus 10, a to the power 3, that will be cos third theta, then b to the power 2, that is I to the power 2, because the power is distributing inside here, so that will be I to the power 2 and sine squared theta. Then we are here, we say plus 10 a to the power 3, that is cos squared theta. Then b to the power 3, so that is I to the power 3, and sine third theta. Okay, so sine third theta, so that would be that. Then we are now here, so we say plus 5a, which is just cos theta, then b, that will be I to the power 4, because the 4 again distribute, then sine fourth theta, then plus finally a to the power 0 is simply 1, so it's good as not writing it, then plus I to the power 5, because we have 5 here, we'll distribute inside here, so I to the power 5 sine 5 theta. So now from here we just simplify, so we have cos to the 5th theta, then this will simply be I, so the I will go outside, so that will be plus I 5 cos 4th theta sine theta. Then we also have, so I to the power 3, I to the power 2 is just simply negative 1, so this will be negative 10 cos third theta sine squared theta. Then we are going to have plus here. Now we are here, I to the power 3, that is negative I, so let me just erase this, so that will be negative I, then we have 10 cos squared theta sine cubed theta. Then we are here, I to the power 4, that is positive 1, so that will just be plus 5 cos theta sine fourth theta. Then I to the power 5, that is simply positive I sine fifth theta. Right, so now that is simplified. We can group the real parts, those that don't have I. So we have 1 is real, this is real, it doesn't have I, and this is also real, no I. So this will simply be cos fifth theta minus 10 cos third theta sine squared theta, and plus 5 cos theta sine fourth theta. So that is our real part. Then we have the imaginary part. We can factor out the I. Then we start with the highest power, so that will be sine fifth theta. Then this is also imaginary, minus 10 cos squared theta sine cubed theta. Then this is also imaginary, so we say plus 5 cos fourth theta sine theta. Right, so we have that too. And remember the question that we had, so this is our question right here. So now we're going to compare. So now what we're going to do is we're going to compare between the real part and the imaginary part. Which one is sine 5 theta equal to? So we see that sine 5 theta is actually equal to the real part of this expansion, which is cos, that is cos 5, is it cos equal to the real part of cos theta. Let me write it properly. So we see that sine 5 theta is actually equal to the real part of cos theta plus I sine theta to the power 5. Okay, so it is equals to the real part of this. So basically, we can say sine 5 theta is equals to the real part of this, which is simply equal to cos 5 theta minus 10 cos cubed theta sine squared theta plus 5 cos theta sine 4 theta. And basically that ends your proof. Okay, so that is how you show that sine 5 theta is equals to that. So you go by that procedure. Now let me put in some few problems for you to solve. So you're going to do these two questions, show that cos 5 theta is equals to sine 5 theta minus 10 cos squared theta sine cubed theta plus 5 cos 4 theta sine theta cos theta sine. And this one, sine 3 theta is equals to negative 3 negative sine cubed theta plus 3 sine theta cos theta. So these are the two questions that I'll be waiting for you to submit. Have a good evening.